Today we're going to be working on lesson 8.7. We're going to write quadratic functions from X-Intercepts, truthfully. So let's put your name up the top of your paper. Let's keep things to you so you have no orphaned papers. The reason we've been doing so many problems involving binomials, multiplying two sets of parentheses together in this unit, is because those individual sets of parentheses actually show you where your quadratic equation is going to cross the x-axis. They're just helpful. So the idea is if we can use the original quadratic function that's in standard form and break it down into its two factored binomials, then we will be able to find out where it crosses the x-axis. So this is a process that you're going to see many, many times. I think today is the first time. So it'll be new, but we'll walk through this slowly together, and then we'll do it a lot of times together on future lessons. Don't worry, it's a process. So to get us started, we need A, B, and C from our standard form quadratic function. A is the coefficient in front of x squared, and if nothing is there, we know it's a 1. B is my coefficient in front of x, so that is a -9. And then C is -70. All right. So what we're going to do is build a box. And put a giant X in the middle of it. Now in the top triangle, we're always going to put the created product of A times C. So our A is 1, and our C is -70. So 1 times -70 is -70. Not a genius. And then in the bottom triangle is always just your simple value of B. Whatever B is, you put it in that bottom triangle. -9 for us. At this point, this is where the work comes in. And it's not horrible. It just is remembering your multiplication and your adding and subtracting and your just a process. So I want to know all of the factors that could multiply together to make -70. There's quite a few of them, and so we need to look at them and find out what we're going to use. So let's see. There's -1 and +70. Those multiply to make -70. Oh yeah, you're right. I could switch it so it was +1 and -70. Okay. How about -2 and +35? Yep, I could have +2 and -35. That works. What's another pair? 3 doesn't work. 4 doesn't work. Oh, but 5 works. So -70 divided by -5. Oh yeah, that's 14. And yeah, I can switch them. So remember, I'm just finding all of the pairs of numbers that could multiply to make -70. And our favorite is when we get to multiply by 10. It's like one of the best things to multiply by is 10. Okay, so that is all of the pairs of numbers that we could multiply together that would make -70. Now what we're going to do is we're going to find each pair's sum. We want to find out what they add to make. -1 plus 70, 69. 1 minus 70, oh, -69. -2 plus 35, 33. 2 minus 35, negative 33. Negative 5 plus 14 is 9. 5 minus 14 is negative 9. Negative 7 plus 10 is 3. 7 minus 10 is negative 3. All right. Why do I do this? I don't get it. It's okay. What we've been doing on the sly is looking for what two numbers multiply to make negative 70, but also add and subtract to make negative 9. So this is where I look through and hey, there's a negative 9. That is what I've been looking for. So this 5 and negative 14 is what goes in what I refer to as the wings of my box. There they are in the wings. Okay, we've done the hard part. The hard part is over and over. So now we're just going to finish this up. And what we have is we're going to build two binomials. Here's my letter X. And we're going to take a wing and divide by A. So you could say the wing is a triangle, side triangle, divided by A. And here's my other triangle on the side, divide by A, if you wanted some symbols, I guess. X plus, so this wing, well, that's 5. Oops, there you go. Sorry about that. 5 over A. What A? That one, right there. Oh, it's just 1. X minus that wing, 14 over A, 1. What happens if A isn't 1? We'll deal with that on a different day. Don't worry about it. I'll take care of you. So, X plus 5 and X minus 14. All it asked for was use the X-intercepts to write the quadratic in a factored form. This is it. This is the factored form. Ta-da! That's what we were looking for. So I walked through all of that with you because I knew that's new. You need to see how that goes. But this is the kind of thing, two binomials, that we're going to be creating again and again for each of these problems. And that's our goal. That will be the most involved one that we just saw. So let's go look at our second example in this handout. Here, they gave me two X-intercepts. These are solutions, they are zeros, they are X-intercepts, they are roots. So let's write that out to the side just to remind us that solutions equals X-intercepts, which equals roots, which equals zeros. So depending on who wrote any given problem for you to tackle, they could use any 4 of those words, and you got to know that they all mean the same thing. So we have the solutions. Let's go write our answer in factored form and then in standard form. So if these are the two solutions, the factored form would be X minus some number, one of the solutions, times X minus the other solution, the other number. This is super friendly, super easy. So let's go do it. x minus, what's the first value they gave me? 4. Ta-da! Second binomial, x minus, what's the second value they gave me? -7. Okay. Make sure you have the minus and the negative in there. Let's clean this up real quick. X minus 4 times, hey, what's a minus and a minus side by side? Yep, it's positive. X plus 7. This is the factored form. Wasn't that great? So easy. We wish we had to do those all day long, huh? All right. Now, this problem is also asking us to go find the standard form. We need to finish this out. So to get the standard form, you're just going to use your FOIL or your distribution or your box method to multiply this through. So let's rewrite it so I don't mess up my nice pretty answer. And let's start the FOIL. First, those two get multiplied together. X times x, x squared. Outer, a positive times a positive, it's positive. X times 7, 7x. Inner, right there. A negative times a positive is a negative. 4 times x is 4x. And last, a negative times a positive is a negative. 4 times 7 is 28. Let's combine like terms. Here they are in the middle. X squared. Hey, what is 7x minus 4x? Do you remember? That's right, it's positive 3x minus 28. And there it is. This is your standard form. That wasn't too bad. That's pretty easy. We like those. All right, let's do the next one together. Here, we're going to use the X-intercepts and the given point to write a quadratic function in the factored form for each parabola. Okay, so let's do that. So first off, I need to know what my X-intercepts are. Here's one, and here's another one. I love problems like this on your state tests because it will ask you, given the following graph, determine the X-intercepts. And you will literally get to look at the graph and say, right there, it is right there. Do it, it's great. It'll make you feel better. Say it just like that. It'll make you feel great. Okay, so that means my X-intercepts are 4 and 7. All right. Let's go find out about your factored form. X minus 4. X minus 7. Yeah, that was it. You're done. Don't you love those? I love those. Now, it did give you this coordinate point, and you're like, but hang on, I feel nervous. Go ahead and show that. Okay, well, you can feel nervous, so here's an option that you can do just to help you. Once you have your possible answer, go check the table for this equation in your calculator. Let's go see what I mean. So, new document. Not going to save. I need a graph. So let's put in these two purple binomials. Let's type them in. Use your parentheses. You must use your parentheses. So parentheses, x minus 4, close your parentheses, times, reopen a new set of parentheses, x minus 7. Push enter. There's your graph. It looks a lot like the graph they gave us in the picture. So let's go check our table. Control T. They gave us the point 3, 4. Hey, that's right there on my table. What a great sign to know that we did things right. So that's how we use our table to help us to know if we did this correctly. All right, I'm going to get you started on this next one, but then you're going to have to finish it on your own. So I need my two X-intercepts. Where are they? Right there. Say it just like that. It'll be fun. Right there. There they are. So my X-intercepts, -5 and -1. Okay, so now I've helped you. We've gotten them. They're right there. Your job is to go write the factored form of the parabola, but there's a catch. After you write the factored form, you need to expand it and go get the standard form. So go multiply your two binomials together and see what you get. If you get stuck, come and ask me. Pause the video. All right, this is the last problem in this packet. We're going to start it off together, and then I'm going to let you finish it on your own. And this topic is also from yesterday. This is a throwback. So let's see if we can remember how to do it. We're going to use the translation from the parent function to write the quadratic in standard form. That's what we're aiming for. So you can start this by looking at your graph and saying, hey, are my x-intercepts nice clean coordinate points? If they are, just use your factored form like we've been doing. Yeah, but no, they're not. Thanks. So since the x-intercepts are not nice clean coordinate points, we need to use the vertex form of the equation. Let's write that down. F of x equals a times x minus h squared plus k. So that means I need a vertex, and I also need a nice clean coordinate point to work with. Let's go find them. Here's a vertex. That vertex is at the coordinate point -2, -5. Let's write that down. H, and K. We also need a nice clean coordinate point. Can you find one? I see 4 on our graph that we could choose from. There they are. I'm going to pick this one. You could have chosen any of those 4, and you should get to the exact same answer as me. But for the sake of making it all together, let's use 0, -1. This is your X, this is your Y. All right, so you need to plug into the vertex form of your quadratic, H, K, X, and Y. Go solve for A. Rewrite the vertex form of your equation, and then expand it to go get the standard form of your equation, just like we did yesterday in lesson 8.4. Let me know if you need help.